Hello, fellow chemists. In this video, we're going to take a look at balancing chemical equations. This is labeled as an intermediate level video because these are a little bit more challenging equations to balance, and it assumes you have the basic rules understood for balancing equations. If you need a review of those rules, I'll put a link in the upper right-hand corner. All right, so we have two equations that I'm giving you here, and we're just going to kind of go through each one and balance it. And what's a little bit new in this one is you have these terms that have parentheses around them. And what that means is everything that's in the parentheses, there's two of them here. So you have two NO3s attached to the Cu. And we'll write that out so we'll kind of see that as we go through the example. So first thing we'll do is we'll just kind of break the equation in half so that we can make sure we get the same number of each type of atom on each side. And again, the first step of the rules are just pick an element and make sure it's balanced. We'll just put ones in here for now because if there's nothing written there, you assume it's a 1. So we'll take a look at silver, which is Ag here. There's one silver on the left, and we got one silver on the right, so that one looks good. Take a look at the second element, copper. There's one copper on the left, one copper on the right, so that one looks good. Now we'll take a look at nitrogen. So we have two nitrogens. Now, how did we get two nitrogens at? So you have this molecule. I'm going to draw the molecule out, Cu. And then it has two NO3s attached to it, NO. And again, I'm not worried about the correct number of bonds or the formal charges or anything on there. I just want to show the atoms so you see how many atoms you have. We'll just draw the Ag out over here. So we have one copper that's attached to two of these NO3 molecules. So there's two nitrogens and then a total of 1, 2, 3, 4, 5, 6 oxygens. And then if we draw this molecule out over here, we have AgNO3, so you have a silver, and that's attached to one of these NO3 molecules. And then we'll just write our copper out over here too. So you can see we have one nitrogen on the right, but we have two nitrogens on the left. So we need more nitrogens on the right. So this needs to get changed to a 2. Right, so now we have another molecule of this. So we have to draw it in. So put another Ag and then NO3. Again, not worried about the non-bonding electrons or bond angles or anything. We just want to see the actual number of atoms. So you got two nitrogens on the right and two nitrogens on the left. But anytime you change a coefficient, you got to start over. So we got one silver on the left, and you got now two silvers on the right. So now we have to change the silver here to a 2. We'll put another silver here floating around. So now we got to start over, check them all again. So for silvers, we have two silvers on the left and two silvers on the right. Look at copper. We have one copper on the left and we have one copper on the right. Take a look at nitrogens now. We have 1, 2 nitrogens on the left, 1, 2 nitrogens on the right. Now let's take a look at oxygens. We got 1, 2, 3, 4, 5, 6 oxygens on the left, and we got 1, 2, 3, 4, 5, 6 oxygens on the right. So this looks balanced. We got 2 silvers over here and 2 silvers on the right. We have 1 copper on the left and 1 copper on the right. We have 2 nitrogens on the left and 2 nitrogens on the right, and 6 oxygens on the left and 6 oxygens on the right. So the final equation to be balanced is 2Ag plus 1 CuNO32 yields 2AgNO3 plus 1 Cu. All right, so that's the first one, completely balanced. Hopefully it gives you a little idea of what these parentheses means. It just means there's 2 of whatever is in that parentheses. And again, as I said in the previous video, once you get good at these, you won't need to draw all of the molecules out down here. But if you're a beginner student for balancing equations, that often helps quite a bit just so you can see how many physical atoms you have on each side. So that's the first equation done. The second equation is kind of similar in that it does have one of the terms that has parentheses around it, so it'll give you a little bit more practice dealing with making sure that you're counting up the elements right that are in parentheses. So here's our second equation down here. So I'll draw it out larger up here so we have something to work with. So we have CuSO4 plus HCN yields, and here's where the parentheses come in, Cu parentheses Cn2 plus H2SO4, and H2SO4, if you didn't know, is sulfuric acid. All right, so again, we're going to divide this down the front. Let's just draw out what these molecules look like here. So we have Cu, and then that's attached to an S with 4 oxygens. 4. And then we have an HCN. So an HCN. Again, I'm not worried about the correct number of bonds here. I'm just counting out numbers of atoms. And then we have CuCN2, Cu, Cn. And we have another Cn because it's a 2 there. It means there's 2 of these. And then we have an H2SO4. So SO. And then there's 2 hydrogens coming off. Okay. So let's start off by taking a look at the copper. We have 1 copper on the left-hand side, and we have 1 copper on the right-hand side. And again, I'll put in 1s for everything to start off with. Then we'll go to the sulfur. We have 1 sulfur on the left-hand side, 1 sulfur on the right-hand side, so we're good with that. Then we look at oxygens. We have 1, 2, 3, 4 oxygens on the left-hand side, 1, 2, 3, 4 oxygens on the right-hand side. So far, everything looks good. And we'll take a look at hydrogens. We got 1 hydrogen on the left, but we got 2 hydrogens on the right. So we need more hydrogens on the left-hand side. So we're going to change this 1 to a 2. So now we have 2 of this molecule, HCN. Now we got to kind of start all over again. So we'll take a look at the coppers. We got 1 copper on the left, got 1 copper on the right. We got 1 sulfur on the left, 1 sulfur on the right. We got 1, 2, 3, 4 oxygens on the left. We got 1, 2, 3, 4 oxygens on the right, so that's all still good. Now we go back to the hydrogens. We got 1, 2 hydrogens on the left. We got 1, 2 hydrogens on the right. Looking good so far. Now we're going to take a look at the CNs. We have 1 carbon or 2 carbons on the left, 1 there and 1 there. And we have 2 carbons on the right, 1 there and 1 there. And we have 1 or 2 nitrogens on the left, 1 there and 1 there, and 2 nitrogens on the right. So it looks like everything is balanced. Let's just write everything up here to make sure. So we got 1 copper. We have 1 copper over here. For sulfur, we have 1 sulfur. We have 1 sulfur. For oxygens, we have 4 oxygens. We have 4 oxygens. And then for hydrogens, we have 2 hydrogens over there. We got 2 hydrogens over here. And then for carbons, we have 2 carbons over there and 2 carbons over here. And for nitrogens, we got 2 nitrogens over there and 2 nitrogens over here. So all of the elements cancel out. So if we take a look, our final balanced equation is 1 CuSO4 plus 2 HCN yields 1 CuCN2 plus 1 H2SO4. All right, that's it for this equation. I hope you learned something. If you did, subscribe and like, and I will see you in the next video.